Good. So the average rate of change, so this function, we know that this is the same with x minus 2 squared. I selected a simple one, so the graph looks something like this. Not that open, but it doesn't matter. Okay, so we selected the rate of change of this function between 1 and 2. So this is 1 and this is 2. So in order to determine the rate of change of this function between these 2 points, I have to draw, basically, or imagine I draw something called the secant line. This has nothing to do with trigonometry. Secant line. A secant line crosses the graph in 2 points. A tangent line, this is a tangent line, tangent, at this point, it touches the graph in only 1 point. The secant line crosses the graph in 2 points. It can cross in more than 2 points. If it's something like this, it can cross in more than 2 points. It doesn't matter, but at least in 2 points, not 1, 2 or more. So in order to find the average rate of change of this function, all we have to do, so the average rate, is the same with the slope of the secant line. Can anyone give us the slope of a line? Secant line or line, same thing.
Change in y over change in x?
Yes, it is. Rise over run. Very good. Excellent. So the rise will be the change in y, f of x2 minus f of x1. And the run will be, in this case,
It'll be x minus x sub 2 minus
x sub 1. Awesome. Very good. So I do have 2 minus 1, so this is 2 minus 1. No problem there. But how do I get f of x2 and f of x1? Because I need to put them up here. So the denominator is very clear, 2 minus 1. But what about the numerator?
You need to drop your x sub 1, which is 1, into your equation to get y.
Very good. So can anyone plug in 2 and give us the answer? Can anyone plug in 1 and give us the answer?
I'll do 2.
Good. So for 2 is?
I'll just do 1.
Okay. Awesome. So what is for 2?
Sorry, it's 0.
Yes, of course. 2 minus 2 is 0. And for 1?
1.
Yes, because 1 minus 2 is negative 1. Negative 1 squared is 1. Awesome. So the numerator is negative 1. The denominator is 1. So the answer is negative 1. What does this mean? It means that between these 2 points, the average rate of change of this function, as we know it's negative because it's a negative slope, it will be negative 1. Keep this in mind. And now let's talk about, stop me if you have any questions. Anyone? Any questions? Any questions? So now let's talk about something called the difference quotient. It's the basis of this chapter. The difference quotient is really the basis of this chapter. So let's take a look. Another function. Here it is. So here's f of x. And I'm going to pick this point P. And if this is x, what will this be? It's a point that lies on the function. When it's x, it's x. If it's 5, then how do I determine the height or the y value at that point?
by plugging whatever x.
Of course, of course, of course. So this must be f of x. Perfect. And let's say that there is a point, so P and Q are very, very close. But if I put Q here, no one will understand what I'm doing. So imagine that I'm zooming in tremendously, and here's Q. But P and Q are very close. But I zoomed in, and the x-coordinate of Q is x plus a little bit. H is tiny. Now, can anyone give us the y-coordinate for Q?
You could get it as an expression of like f of x plus h.
Thank you very much. Perfect. Now, what is the difference quotient? In a moment, you will see. This is like the previous situation. The previous situation was the same thing. We were asked to find the average rate, and it's basically the slope of this secant line. So what we are going to create, again, just imagine that I draw this line through these 2 points. So I want to determine the slope of the secant line PQ. Exactly how we did it a few minutes ago. So secant line PQ. Can anyone tell us what it is? Tell me what it is and I will write it. You know how to pin the speaker so you can see this on your entire screen, right? Okay, good. So the secant line PQ, the slope of the secant line PQ. Can anyone dictate?
Would it just be doing rise over run?
Yes?
So let's see. Wouldn't you start with f sub x plus h?
It's not sub, it's f of.
F of x plus h.
No, it's f of x plus h. Good?
So
Good. Next.
minus
Yes?
f of x
Awesome. Over.
x plus h minus x.
That's it. It has to be the same thing. What you see here has to be in the denominator. These two are gone. So then we have f of x plus h minus f of x divided by h. This is the difference quotient equals the difference quotient. So what is it? Same thing. It's the average rate of change of a function between 2 points, P and Q, where P and Q are very, very close. Why do we even discuss this? What is the purpose? We already have a concept. We have the concept of average rate of change. Why do I need the concept of the difference quotient? Because the concept of the difference quotient is the one that will take us and help us determine the slope of this line. Okay? This is what I want. I want the slope of the tangent. This is what I'm after. And how do I get here? By moving Q closer and closer, closer and closer to P. Here's what happens. Looking for my ruler. So here's what happens. Okay, ready? So if I start here and I bring Q closer, then I have this secant line. I bring Q even closer, then I have this secant line. I bring Q even closer and I have this secant line. And closer and closer and closer, and I get the slope of the tangent line. Okay, now why do I need the slope of the tangent line? Who cares about the slope of the tangent line? Well, and here is one explanation. If, let's say, f of x is the distance function, what will the slope of the tangent at P represent? So first of all, what will the slope of the secant line represent? The average rate of change between two spots on my traveling to, I don't know, New York. But what would the slope of the tangent line at P represent?
The instantaneous.
The instantaneous velocity or rate of change. Please remember that the instantaneous velocity or instantaneous rate of change, like the slope of the secant line, like the average rate of change, will have two measurement units. One measurement unit coming from the rise and one measurement unit coming from the run. So please remember that.
What's meant? Sorry.
Yes, go ahead.
By instantaneous velocity. Is
Oh,
that the rate of change up until P?
no. Very good question. Very good question. Okay, so I'm driving to New York. Okay, so I'm looking at the time on the video. So I'm driving to New York. I have 200 miles from Baltimore to New York, and I come back and you say, can you please tell me what was your average rate of change, speed? What was your average speed between Wilmington, Delaware, and Newark, New Jersey? So I will measure the distance. I will look at the time. Okay, I was at 2 p.m. in passing by Wilmington, and I was at 4 p.m. passing by Newark, New Jersey. I will divide the distance by the 2 hours, and I'll tell you that was my rate of change, my speed. Now, I'm driving, and you call me and you say, what is your instantaneous rate of change or velocity? Well, I have to look at the odometer. I don't know. So when I look at the odometer, I'll say 45 miles an hour.
Okay. So it's not your average, it's your speed at P.
At P.
Okay.
Exactly. That's why it's given by the slope of the tangent. It's not given by the slope of the secant line. The slope of the secant line will give us the average rate of change or the average speed between Wilmington and Newark, New Jersey. But when you say that I can't calculate that unless you give me the function. But if I don't have the function and you call me and you say, what is your own? I'm going to say, well, traffic is slow. I'm driving 45 miles an hour.
Wait, so you're saying it's basically the speed at that current moment?
Current moment, instantaneous speed, yes. Exactly. It's not on average speed over a span of a distance. It's the instantaneous velocity at that moment. That's why it's called instantaneous. Good. So now I think these are the preliminaries that I wanted to go over quickly. And now I would like to basically start chapter 2. Okay, so I would like to open the book. Give me one more second to open the book in the background in WebAssign. Where's my keyboard? As you notice, my device is so far away from me that I have to have remote access to everything. So based on what we just discussed about the average rate of change and the instantaneous velocity, I would like us to choose a problem and work on the problem. You can choose anything you want, or I will choose. I just go to the ebook. Okay, and I'm going to share my screen. So once you go to, when you click on the ebook, we are going to click on chapter 2, limits and derivatives. So in my example, the distance was, the function was the distance, but it can be profit. And then the slope of the tangent line would be the average rate of the instantaneous rate of change of the profit, and so on and so forth. If it's volume, then it will be the instantaneous rate of change of volume with respect to time, with respect to pressure, with respect to who knows. These are just examples. Okay, so well, there is a function. Is it okay if we start with problem 5? That's basically all we need. We just need to illustrate with one problem here. Is that okay?
Yeah.
Okay, so this is 5 in 2.2, 2.1, of course. So the deck of a bridge is suspended to 175 feet above a river. If a pebble falls off the side of the bridge, the height in feet, so this is y, it's in feet, of the pebble above the water surface after t seconds. So I take notes, t is in seconds, y is in feet. Always remember that. So then y is 275 minus 16t squared. Find the average velocity of the pebble for the time period beginning with t equals 4. So we are interested in t equals 4 seconds, and lasting 0.1, 0.05, and 0.01. Okay. So then estimate the instantaneous velocity. So let's start with this first. Okay. So it says lasting 0.1. So if this is the point with t equals 4, what will be the next point? So 4, of course, y of 4. Y of 4. What is the next point? If the time is, in other words, we're looking at starting from 4 and it's lasting for 0.1 seconds. What is the second point? If this is P, what is our Q? We need to identify that.
4.1.
4.1, comma, y of 4.1. So we have 2 points, 4 comma y of 4 and Q 4.1 comma y of 4.1. So this will be the first point, or the first discussion. What about the second one? We don't have to write all 3, but let's write one more. So if P is 4 comma y of 4, what is the next Q?
0.05.
Yes, so 4.05 comma y at that point, 05. Good. Okay, so here's what we are going to do.